Hello, my name is Kevin, and today I will be discussing the relationship between pressure and velocity. Um, so basically, as we take a first look at the first picture up, I already have a conclusion set that velocity can equal infinity and pressure can equal zero. But in order to understand this, you would first have to understand what it means for something to be inversely proportional. Basically, y from the formula is a value, x is a value, and k is a constant. As the value you see was y equals k over x. Now, this basically shows as x increases, y decreases, and x decreases, y increases, according to the constant. This definition is of an inverse relationship, and it could be used to describe velocity and pressure. But before we get into that, I would want to show you an example of the formula for inversely proportional and how it works. So this example is set up where it's y equals k over x, where y base 1 is 10 and x base 1 is 5. What would the constants be? So the first step would be finding the constant in the first place. I was just substituting first, so y equals 10, 10 equals k over 5, and basically the x gets substituted in by 5. So what you get from this is that you do, simple algebra, and you come down to the conclusion that k equals 50. Now that you have a constant, some other information is given to you, that is y base 2 equals 100, and now you're trying to find x base 2. So the way you find x base 2 is basically you do the same, you substitute for the y, and instead of substituting the x, which you don't have an x, you would have to substitute in the constant, which is 50. And once you, as you can see on the right side of the board, you use basic algebra to solve that. X base 2 equals 1/2. And in conclusion to that, as y decreased, as y increased, x decreased. Y went from 10 to 100, and x went from 5 to 1/2, just through that. Now, as we look at the formula, we could actually compare this to the velocity and pressure formula for it being inversely proportional, and it is actually a relationship between the two, where as pressure increases, velocity decreases, and vice versa. Within this demonstration, v and p, just like x and y, are values, and k continues to be the constant. Now, instead of doing the old example that we did, we're going to take this one step further, and we're actually going to compare the values to 0 and infinity. Now, in order to compare the relationship between the values, p would be equal to 0 in order to make v equal infinity. Sadly, there is a flaw. In order to make velocity equal infinity, you would have to make p equal 0. But according to the laws of mathematics, any number divided by 0 is undefined, right? As you can see, slope equals 0 when a line is horizontal, at least, and slope is undefined when the line is vertical. But through this formula, you have k over p, and for k over p, where k is any constant value given any number imaginable that you could think of, from negative infinity to positive infinity, any single number can be given as a constant. And basically that over p, let's give it 1 over p, would basically create the graph that is shown at the bottom right of the board. So basically the representation on the left side, bottom left side of the board, basically is the first quadrant. And what the first quadrant explains is how as x reaches 0, y shoots up and reaches for infinity. Now, this is basic geometry. Obviously, you could create a graph, and I named it velocity versus pressure, because velocity would be the y value, pressure would be the x value. Also, they're both represented by v or p. Now, what happens is that this could actually describe a limit function, and how, as x approaches a certain number, y continues to increase or decrease or whatever. In this case, as x approaches 0, y reaches infinity. And you actually, instead of basics of geometry, you get the basics of calculus. Now you're introduced to this called the limit. Limit as x approaches 0, f of x would be what? F of x would be a mystery to us if we didn't know what x was trying to reach. But since we do know what it's trying to reach, x is actually approaching 0, and f of x, which is basically p, or v, I mean, would actually try to be infinity. And basically the reason for that is that once you have something like 1 over 0, where if pressure was 0, you would actually reach an undefined number, infinity. It would never stop growing, considering that 1 divided by a smaller number every single time would start to increase the number that's given. And as the denominator, which would be x, represented by x at least, would slowly start to decrease, then the number will slowly start to increase. So let's say the x value becomes 0.01 or 0.001 or 0.0001, or until it reaches something so nearly close to 0 that the slope, basically the slope of the point on the graph would almost be infinity. It would be such a high number that it's it's almost incapable to keep up with. After this, it's defined that this formula reveals that pressure P is reaching 0 and velocity is the outcome or the function of the entire equation. And basically what this is meaning is that pressure could only get as close to 0 as possible but never truly reach it. And this is also described by the same formula that we saw before, which was V equals K over P. And you can turn that into V equals K over 0. Now the reason we don't need a constant for this certain equation is that because the constant is any given number, anything over 0 is going to be undefined. But in this case it's going to be infinite because the slope would be reaching vertically. It would be, in fact, the velocity at that certain stage would be so intensely high that you would basically be teleporting from one given point to another. Basically meaning that you're going from one point, traveling that distance, reaching another point without using up any time. And that time frame is important because that's what describes momentum. Now, it finally concludes that velocity equals infinity. But the thing is, velocity can't really truly be infinity. Now, this is in accordance to the limit of as p approaches 0. F of p, which I'm stating the function f of p is v, which is k over p, would equal infinity, thus f of p being v. And from this you can actually conclude that v equals infinity. And again, the one flaw about this is that p is trying to reach 0. It's always going to try to reach 0, it's never going to get to 0. And the reason for this is that it's just undefined. It's mathematically impossible to divide something by 0 without getting something infinite that keeps on growing and never stops. Something that's uncountable by any human. Finally, in conclusion, we get v can't be infinity because p never reaches 0. And that's basically what I was trying to prove during this whole video, that velocity can never reach infinity. Because again, within a time frame you would be traveling from one distance to another with no time, and you would need time in order to move in the first place. Pressure itself can never really be 0, because then that would occur. Velocity would actually, not be determinable by the distance traveled. And what I mean by that is that velocity with the distance traveled would use up no time, v being distance over time, or at least total distance, the total displacement over total time. And keeping that in mind, with 0 as time, you would basically get an undefined number. And that's my conclusion for this. Thank you so much for watching. I hope you all liked it, and good night.